morning, grade sixes. Welcome to STEM Lockdown Digital Skills. So awesome to be back and awesome to have you. I just want to say thank you very much for the emails. And I've got 2 emails from 2 learners who are asking for some notes. So I am absolutely working on that. So I've saved actually your names on my desktop so that I can make sure you get notes. Okay. So don't worry, I am on to that. And the other thing I wanted to say is, if anybody else wants to get some notes, please send me just a note or a message to sheenamelody@gmail.com. And then I can also help you, because if I'm sending to 2 students, I can send to a lot more. So notes will be ready for whoever needs it. Okay. Right. Are we ready to begin? Okay, let's see. I am doing very well. Thank you for asking. Thank you so much for asking. I am doing good. Not too cold today, thankfully, so that's not too bad. All right. So today we are going to continue a little bit from yesterday's lesson, although we did quite well with time and with our definitions and meanings. So I am going to introduce something else today as well, some insolubles and solubles. So this is where we stopped yesterday. Okay, so we did heterogeneous and homogeneous mixtures, and you actually, guys, grade 6s, you did awesome. You definitely get a pat on the back because you really seem to understand the difference between the two and how to recognize them. So I'm extremely proud of you. So well done, pat on the back. These were some examples that I just put up to show you that I know you're quite familiar with. So this is where we stopped round about yesterday. We were writing what the meaning of a solution is and that it's a homogeneous mixture. We did also get a question yesterday where we were asked, I think it was Kiara, that asked me if the coronavirus is homogeneous and heterogeneous. And we agreed that it was homogeneous because you couldn't see it really, and it could spread with liquid like your saliva and sneezing and things like that. So yes, we also discussed that a little bit. Very good, informative question, so well done there. This is the diagram we did, which I encouraged you to draw because sometimes visually seeing it is a good idea, and you often will be asked draw a diagram of how to make a solution. Often when you see a question presented in a test paper or an assessment or something, you might be thrown off track because it doesn't look quite the same as when you probably were learning it. So when they ask you to draw how to make a solution, this is what it is. It's very simple and very clear. You can mention the solute plus the solvent equals the solution, and you can draw them. And then you can give examples underneath and say salt, water, and salt solution. So that's a nice representation that you can use. So I think you did definitely get this down. Okay. We then started talking about solubility. All right. How that when we measure how a solute dissolves into a certain solvent, it's called a measurement of solubility. You get high solubility when a solute dissolves quickly and easily, like salt in water. We get low solubility when it doesn't dissolve easily, like sand in water. Okay. So this was covered yesterday as well. And then we did some examples. We did examples of dilution versus a concentrate. Okay, so we can add a little or a lot of a solute. For example, putting spoonfuls of sugar into a cup of tea or coffee. A solution with a small amount of solute is called a dilute solution. And then you can add a lot of a solute, and a large amount of a solute added is called concentrated. Okay, now saturated solution is when you It's so much solute that the solvent cannot hold anymore unless you increase its temperature. Okay, so I think, were you with me so far? This was I think the last example. By heating a solvent up, it can hold even more solute. So the hotter it is, the more solute you can add. So a supersaturated solution contains more solute than it normally would dissolve if you heat it up. These were the examples of what we discussed in the whole lesson. I'm sure you did get these notes out, so I'm not going to stay on this page for long. Okay? Saturated. A concentrated solution is when there's more solute than solvent, and a diluted solution is there when there's more solvent than solute. And then saturated solution is when there is so much solute that it can't dissolve. It becomes saturated. If you heat it up, it can eventually dissolve. Okay. Right, so let's look at something a little bit different. Do you know what crystal is? Any examples of what a crystal is? Okay, so good. So we're going to learn something maybe a little bit new today. Maybe some of the information you know, maybe some of it you don't. Okay. Now, I don't know if you've ever visited a cave. Like when we were in school, we used to visit the Kango Caves quite regularly. It was one of the most famous places to go and visit. And even when my little boy was growing up, I also took him to the Kango Caves. When I was younger, we were able to go a lot deeper into the caves, and there were little tunnels we were allowed to go into. However, at the moment, when I was older and took my son, there were certain areas that were actually closed off because they were being destroyed. So when people touch things a lot, it gets worn away and destroys the natural process of these things. Okay. Now, if you've never been to a cave, maybe put that on your things to do list that you want to do one day. There are a lot of caves you can visit in South Africa. Obviously, the most popular one is the Kango Caves. However, I'm sure there are far more. Now, when you walk inside a cave, I'm sure there's a virtual tour. Maybe you can Google it and do a virtual tour of a cave online. They often have virtual tours of famous places. So maybe Google that and look it up, or I can do that for you and see what we can find. Because I think even if you can't physically go and visit a cave, maybe you can virtually visit one. And then you can exactly see what we're talking about. Okay. Makona has asked me to go to the previous page, so I'm just going to go there so he can put this page down. Okay. Yes, on Google Earth, maybe they do have that. Morning, Leah. Welcome. All right. So let's see if we can find out a bit more about virtual caves. While some learners are going to be taking notes, we can discuss this for a little while. Okay, so a virtual cave tour. Let's see if we can find one. It doesn't matter if it's not in South Africa. It can be anywhere in the world, because it's still interesting. Okay, so we have on the National Geographic site, if you go to the National Geographic site, there is one that you can go on like a field trip. And this one's nice because it's actually a virtual field trip in a crystal cave, which is what we are talking about. We are actually talking about a crystal cave. So I'm going to see if I can't actually type in a link for you. See if I can get it. see if I can get this link. I'm going to type it in here, and you can just, I'm going to type it in the box here, and then after the lesson, you can actually go and you can have a look. So I'm going to share it with everyone. It's called, the company that presents it is called PALCS, okay, and they present a virtual trip, but I like this one because it's a crystal cave, which is what we are going to be talking about. So it's called a virtual field trip, and it's of a crystal cave. So if you type that in your Google, you will see, you will be able to find it. Now, this isn't one in South Africa, okay? It is a historical site, and it is very, very, very interesting. I think it is in, if I can see correctly the details, I'm trying to see where, where it actually takes place. This was actually taken last year, this video. Okay? It was actually videoed last year, so it's a recent video. It's not an old one, which is why I also like it. Okay, it's not an old one. It's quite fairly new, and it's got some very, very good reviews. All right, so I would watch that after the lesson. Okay, now let's just go. Here we go. Sorry, I moved a bit ahead. Okay, so when you go to this virtual cave, the lady, the guide will actually point out to you the different things we are going to talk about today. Okay, so when you go inside the cave, there are many formations. There are crystal formations, and we call them stalactites and stalagmites. Now, these generally form inside limestone caves. So you get different kinds of stone. Limestone is a very soft stone, and therefore it's probably more likely in the way that it formed from limestone because it is soft. So the stalactites hang down, okay? So the stalactites are the ones that hang down, okay? And the stalagmites come up from underground. So the limestone that develops from above you, above in the top of the cave, is called stalactites, and those at the bottom are called stalagmites. You might actually even learn this in geography when you learn about caves and nature and how things change. Okay, so now how does the cave form in the first place? Well, a cave is when water goes into a rock regularly and powerfully and consistently over time, and it creates a cave. So the water actually dissolves the limestone underground. Okay, and then this limestone can crystallize when the water evaporates. Now, this doesn't happen very quickly. This happens over thousands and thousands of years. It's a very slow process, and that's why they try and look after the caves, because they truly take thousands of years to even become a cave. The same thing with the stalactites and stalagmites. They also take thousands of years to develop. They don't just develop overnight. The process is incredible, because if you look at, I just want to show you a picture. If you look over here, there you go, you can see we've got the Kango caves in Oudtshoorn. They are actually quite awesome. Look at that. What do you think of that? Those things hanging like icicles from the top are actually your stalagmites. The stalactites, the stalagmites that grow up from the bottom sometimes even touch the stalactite and join with the stalactites at the top. So it looks like a pillar. It almost forms like, if you can look on the right-hand side in the photograph, you can actually see it looks like a pillar that we have there. Okay, so let's have a look if you can see from the bottom that they also say that you see the stalagmites coming up from the bottom. They apparently develop in pairs. So the stalagmites develop and form in pairs, whereas the stalactites, as you can see, they're just like random all over the place. Okay. So to bring it down to a simple explanation, okay, any material that is soluble and can be deposited or is in suspension or is capable of being melted may form a stalactite. Okay. So it hangs from the ceilings of caves, hot springs, sometimes even man-made structures as bridges and mines. So it is made from a material that is soluble. Okay, that's where it comes in to our discussion on solubles and insolubles. All right, a stalagmite is the one that rises from the floor because it's material like the limestone material that is deposited from the ceiling drippings. It drips from the ceiling and it deposits on the floor and it gathers up and adds up and builds up. All right, and then becomes a stalagmite. Now, stalagmite can be made from lava, believe it or not, sand, mud, heat. In these cases, particularly, it's limestone. All right. So now we can see that they are soluble materials. All right. Now, there are substances that don't form solutions when we mix them with water. Whereas the stalagmites and stalactites are mixed with water. The limestone is mixed with water, so therefore it forms a stalagmite and a stalactite. However, there are substances that are not soluble in water. Sorry about my doggy there. She's a bit excited at watching the other dogs outside running around. Okay, so I see someone asked me to go back quickly. Okay. You want me to go back to this page or the previous one? This one. Is that right? Who needs to write this down? Just let me know so that I know what's happening. Is anybody still writing? Okay, so I'm going to let you put that down, okay, so that you have it. So I'm not quite sure if you've done this before. Okay. I haven't gone anywhere, don't worry. I'm waiting. I'm just giving you an opportunity to write this down. If you want to write the notes, you don't have to write the notes, but if you want to write the notes, you can write the notes. So what actually happens is, I'm actually going to read through this so that maybe if you hear me read it, it would also help. Caves form when water slowly dissolves the limestone underground. The dissolved limestone can crystallize again when the water evaporates. This is a slow process, and it happens when water drips down from the ceiling of the cave over a long period of time. The water drops that land on the floor of the cave also evaporate over time. And where they fall on the same spot repeatedly, a stalagmite eventually forms. Over many thousands of years, the stalagmite and stalagmite may connect to become a column, as you can see in the images. All right. In this image, you can actually see that taking place. There you go. Okay, you don't need to draw this image. Okay, now insoluble substances, basically, when they're mixed with water, they don't form a solution. All right. So now remember, we were doing a lot of discussion and experiments on mixing solutes and solutions. Why does it only happen with limestone? Well, limestone is a very soft material, a very soft stone. Okay. I don't know if you know that in certain, for example, I don't know if you know a lot about the country Israel and Iran and Iraq, and in those places, they have a lot of limestone. Okay. And it is it's a sedimentary rock. Did you learn about sedimentary rock? Have you learned about sedimentary rock? Okay, last year. So you learned about it last year. Okay. So let's see if I can explain this without confusing you. Okay. The limestone can dissolve much easier. Okay. So it becomes it's easily dissolved. All right. So when rainwater picks up the carbon dioxide from the air, okay, and this slowly over time affects the limestone that is the cave's made from, because the limestone is a very soft, let's put it this way, it's a very soft rock. Okay, it's a very soft rock. If you compare limestone to any other building stone, you'll find that limestone is mostly used to build buildings from in certain countries. Okay, and the reason for this is because they're easy to cut, easy to shape, easy to build with. All right. Whereas other rocks are a lot harder. You need like literally machinery to cut them and to shape them, or very high furnace to heat the rock to a point where you can make it malleable. All right. So I'm just letting, we have some, welcome, Michael. I'm glad you're here. I'm allowing the students that arrived now to just take down these notes for a moment. So if I go quiet, don't panic. I am here. So you can just take it down. Okay. When the water evaporates, yes. Okay, so the scientific description for this is that the rainwater that comes through the top of the cave picks up the carbon dioxide in the air, okay, and as it percolates or as it goes through the soil, it turns into a very weak acid. And this weak acid from the carbon dioxide dissolves the limestone. And then when it's dissolved enough, it becomes big enough to form a cave. Someone mentioned Sterkfontein Caves. That's also a limestone cave. Okay? And it ranges over many, many, many kilometers. So mostly it's the acidic water. So when the water mixes with carbon dioxide, it becomes acidic. And that acidity actually is what dissolves away the limestone. Now, you may wonder why limestone? Well, look where the sedimentary rock is in the earth. Look, the earth is in different layers of rock. So the limestone is permeable and it's soluble. So it gets eroded by the water, and this acid eats at it eventually so that it dissolves and it erodes. And that's why it forms these large cavities in the earth, which we call caves. Does that make a bit of sense? Okay, so essentially it's science. Okay, it's scientific. Carbon dioxide forms carbonic acid when the water reacts with the carbon dioxide, and that acid eats away at limestone. I think that's a simpler way of putting it. Alrighty, so how are we doing with our notes? Okay, don't worry. Now, anything like, for example, I'm going to use a very, very basic example. If you take clay, let me use clay. If you take clay and you mix it with water, it becomes soft, and you can mold it and form it into a shape. All right. Once you finish forming it into a shape, you can leave this clay in the sun or bake it on a high temperature so that all the water is evaporated. Then yes, it becomes hard. So when water can make things soft. So limestone, with the acidity from the water and the carbon dioxide, it becomes soft, but as soon as that water evaporates, it becomes hard. That's why it can form those columns. Has there ever been a man-made crystal cave? That is I don't actually know if there's ever been a man-made crystal cave. Because generally crystal is a natural occurrence. What does the class think? If you're using a laptop, how do you do a screenshot? Okay, so let me put this here. So you're going to click on No, I'm originally from the Eastern Cape, and I now live in the Western Cape. There are man-made caves, not crystal isn't man-made. For example, you guys know about mines, right? Mines are man-made openings, and they were designed to go and dig into the earth to extract materials. Okay. Now, those, because even though the openings are man-made, all right, the limestone process, the crystallization process, can still occur in the opening because of the mixture of water that seeps through, and when it mixes with carbon dioxide and becomes that acid that eats away at the stone. So although the crystallization process is not man-made, there are man-made caves, especially common occurrence is mining. Okay, very common occurrence. Now we have a word for substances that are not mixed with water. These are called insoluble substances. Now, soluble substances dissolve in water, but insoluble substances, they don't dissolve at all, okay? So water is not the only solvent that we can use to dissolve substances. Some substances which are not soluble in water or other solvents, and when no more solute can be added to dissolve a solution, we call it a saturated solution. An unsaturated solution is one where it is possible to dissolve more solute in the solvent. As you do know, solutions are special kinds of mixtures. So how do we decide whether a mixture is also a solution? Okay, so we are, welcome, blessing. We are talking about soluble and insoluble substances. Okay, soluble are substances that can dissolve in water, and insoluble substances that cannot. Okay, so let's look at this. I'm just going to read what someone is sharing with us. I've been to a diamond mine inside, and I saw how diamonds get separated from the soil. It's very interesting in the process it goes through. That's very interesting. That must have been quite an experience. Very interesting. So here is a nice table that you can have a look at. We have questions about the mixture, and then we're going to see is the mixture a solution and if it's not a solution. Okay. If you can see the solute in the solvent, if you can see the salt in the water, for example, then it is a solution. If you cannot see it, it's not a solution. Do you want me to go back? All right. Is this the page you want me to go to? Okay, who would like to take notes on this page? Okay, so I'm going to stop for a moment on this page so that you can take down the notes for those of you that don't have it. Who would like to give, while we're waiting, an example of an insoluble substance? An easy explanation, one that you found that worked for you or that helped you understand. Toy. And before it became a toy? Something you don't know. All right. Well, then that's something we can learn. Okay, so the easy way to say it is, remember when we were discussing water earlier on and we were doing examples of different solvents, and I said to you that oil on its own you can pour. If you mix oil and water, you will notice that the oil does not dissolve into the water. So that is an example of insoluble. Sand, very good. Sand is an example of insoluble. It doesn't dissolve in water, it just becomes mud. Very good. So wood is another example. Earlier on, you mentioned toys. Toys made of plastic or made of wood, you're absolutely right. They cannot dissolve in water. So that's basically what an insoluble substance is. Now you can separate an insoluble substance by filtration. Okay, we have those different systems that we use that we discussed earlier. So we can do it that way when we want to separate them. Okay, so these are the questions you ask to figure out if a mixture is a solution, if it is not a solution. If you can see the solute in the solvent, if you can't see it, it's a solution. If you can see it, it's not a solution. My throat's getting going away now. Oh my, happens every time. Can you dissolve corona in water? It's a virus. So I think it can spread with water. It can definitely spread with water. Now, if the solute settles out, like you mentioned, sand, then if it does, it's not a solution. If it doesn't, then it's a solution. So I think maybe what you should do is just write this note down. Okay. If you look as well, can the mixture be separated using filtration? Can the mixture be separated using evaporation? Those are also two things you ask. Okay. If you cannot separate a mixture by filtrating it, then it is a solution. If you can, it's not a solution. All right. Can the mixture be separated by evaporation? If it can evaporate, like water evaporates from limestone, then it's a solution. If it can't evaporate, it's not a solution. Okay, so are we going to dissolve it in hand sanitizer? Really, grade sixes? I think it's as simple as we want it to be, hey? Okay, are we writing this down? Because I don't want to move on if some of you are jotting this down. Yara, you should never apologize for taking notes down. I would rather you have the notes than not have the notes. Michael, how good are you at making science notes? Because some of the examples you've given this term are very, very good. That's why I'm asking. Snapshots future. Okay, guys, you're counting down. It's making me nervous. Katie and Michael, I just want to find out, do you guys have notes or would you also like some of our notes? If you do, just email me, okay? If you also, or if you want to share your notes with me, some of your examples I absolutely love, and some of your questions I really like. It really gets the mind going. So please just email those suggestions to me, email those questions to me. Then we can always like build on that. Okay. Honestly, I would absolutely love to hear from you guys. I'd love to hear some of your questions. I'd love to hear some of your notes and how you learn and how you see things, because it's pretty cool. I really like this. Now, the other thing is tomorrow we are going to do Kahoots. Yay! Okay, so we're going to do Kahoots, and hopefully it will be a lot of fun. So I hope I see you the same time in the same place tomorrow. Okay, same time, same place tomorrow. All right. Have a great afternoon. Thanks for joining me. I loved having you guys. And remember to email me.